So before we begin lesson 6.11, we're going to review some things from a previous chapter. So I'd like you to take a look at the screen on your own paper. You will need a pencil, most likely not a calculator, but definitely those two things for today. What are our similarity rules? There were three that your textbook introduced you to. We added in a couple of additional ones. If two triangles are congruent, what does that statement mean to you? And then, are all triangles that are congruent similar to each other? And if the answer is yes, what additional piece of information is needed to be able to say that similar triangles can be congruent, and they're congruent when this additional piece of information exists? When you're finished, you can turn the video back on. You want to do one question at a time and then turn the video on and off as we go through that to adjust your thinking and answers. That's perfectly okay as well. So the three rules from your textbook, we started off with angle-angle similarity. We also added side-side-side similarity and side-angle-side similarity. The two that we added that your textbook doesn't address is hypotenuse-leg similarity and long side, short side angle similarity. Hypotenuse leg is actually a special case of long side, short side angle because the hypotenuse is always the longest side, the leg is shorter, so it falls into that side-side angle case. For two triangles to be congruent, what does that statement mean? That means that the triangles are identical in every way. That means that corresponding sides have the same length, corresponding angles have the same measurement. So in the last statement, are all congruent triangles similar to each other? And if the answer is yes, then what additional piece of information is needed? So for triangles to be similar, they have to fit one of our patterns. So if a triangle, for example, is similar by angle-angle, if the triangles to be congruent, what other piece of information has to be there? And for angle-angle, the problem is for triangles to have corresponding sides that are equal, we wouldn't have that information with just angle-angle. So for angle-angle, proving triangles congruent without a pair of sides just can't be done. For side-side-side, if triangles are similar, for triangles to actually be congruent, what we would need is that the corresponding sides have a scale factor or zoom factor of 1. As long as the scale factor between corresponding sides is 1, then that means the triangles are the same size, right? And that means that all the angles and will also be the same measurement. For side-angle-side, same thing, the scale factor between corresponding sides has to be 1. That would also be true for the other two similarity rules as well. For the, we'll say triangles are congruent, scale factor between corresponding sides is 1, and that makes them identical. Now for similarity, we use this symbol, which means same shape, same shapes, but not necessarily the same size, but they can be. And the congruency symbol looks like this, which means same shape, or shapes, I should say. And with the equal sign underneath it, same size. Same shape, same size. So the equal sign is the difference between the shapes being scaled copies that are not necessarily the same to they got to be the same because the scale factor or zoom factor between corresponding sides is 1. So the first problem in 6.1 is asking you to create a flowchart. Now we've not done flowcharts There's very little discussion about flowcharts at this point. So whenever I introduce the idea of flowcharts, there are two critical questions. When you look at a picture, what do we know? Sometimes the information may be given to us. Sometimes it may be we have a definition or a rule, such as the angle sum rule, for example, or for, let's say, for example, if you have parallel lines, all interior angles are equal in measure. We have a rule, or we have a definition, such as if I have an isosceles triangle, I know there are two equal sides. And we can use that additional information as things to help us prove things. So what do we know? And then because of what we know, what now can we say has to be true about our shapes. So in 6.1, I'd like you to kind of look at the picture and just write down what do we know, and do we have enough information to be able to say the triangles are similar? Do we have enough information to be able to say the triangles are congruent? And that's kind of what they're asking you to do in problem 6.1. So the flow chart for this problem is going to look something like this. What do we know? And when we talk about flow charts, especially if we're starting off with these triangles, we're going to try to use our similarity rules. That's the first thing. Are the triangles similar? So we have to either have side angle side, side side side, long side short side angle, even hypotenuse leg. There are three pieces of information. For hypotenuse leg, we have right angles. Or if we're using just angle, we have just two circles, two loops. So what do we know? And then is it enough to be able to say the triangles are similar? And by what reason? And then can we also then say the triangles are congruent? And if so, by what reason? So go ahead and copy down the flowchart and be thinking about, based on this problem, do you think the triangles, do we have enough information to prove that they would be similar? And so which rule would you use? And then based on our conversation about congruency, do we have enough information that then say the triangles also have to be congruent? So once you're finished and you've filled in the top three loops and thought about the other two statements, turn the video back on and we'll go through the problem. So what's given to us? Well, we have three pairs of corresponding sides that are the same length. So again, you may not have written it this way, but this is the way I prefer to see it written. So when we talk about triangles being similar, they got to have the same scale factor. So if I take AB, which is 6, and I divide it by FD, which is also 6, that scale factor between that pair of sides is 1. If I take AC, and if I divide that by EF, that scale factor is also 1. And if I take BC, and I divide it by ED, that scale factor is 1. So I have three pairs of sides that have the same scale factor. Therefore, the triangles are similar by side, side, side. So that's the first part of 6.1. Then to be able to say the triangles are congruent, we have to have two things. We have to have, first of all, that the triangles really are similar. That's that top piece of the symbol, the congruency symbol. And then therefore that would be side, 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 similarity. And the second part is, for the triangles to be congruent, the scale factor between corresponding sides has to be 1. And that's true based on the given information. So in problem 6.2, you have 4 problems. And what we're going to be doing is deciding the triangles are congruent. And so the question I'm going to keep asking as we go through this chapter is, what do we know? And then what can we say? And so in this case here, they're asking you to prove that these triangles, are they congruent? To be able to prove triangles are congruent, the first thing we have to prove is that the triangles really are similar. We don't have any congruency rules. That's actually going to come up in lesson 6.1.2. But what we do have are similarity rules. And if we can prove the triangles are similar, that's step 1 in proving triangles are congruent. Step 2 is, do we have that scale factor of 1? And if we do have scale factors of 1, then between corresponding sides, That's that second piece, and then we have shown the triangles have to be congruent. So go ahead and look at this problem here and decide, do we have enough information to say the triangles are similar? And go ahead and complete this part of the flowchart. And I've already kind of given you a hint here that we only need two pieces of information to be able to say these triangles are actually similar. When you're finished, turn the video back on, and then we'll finish up the rest of this proof. All right, so hopefully you indicated that angle ABD is congruent to angle CBD. That would be the two angles up here at B, and that's given to us. So on the outside, we're always going to give the kind of justification of why we're able to say this. Sometimes the justification is simply that it's given. And then because AC is a straight segment, then that means the other angle on the other side of point D also has to be a 90-degree angle. So angle DB and angle CDB, those two angles have to be congruent to each other. Again, that top angle wasn't actually given to us, but because the reason that's true is because AC is a straight segment. And we know that the angle CDB is 90. So angle ADB is also 90. Because we have a straight angle. Sometimes the justifications are not really simple, like just given or side. Sometimes the explanation has to be lengthy. But the triangles themselves, they are similar by angle. So triangle ADB is similar to triangle CDB by angle. So just because the triangles are similar does not guarantee the triangles are congruent. So to be able, I'm going to scroll down here, to be able to say the triangles are congruent, we have to have one additional piece of information. So going back to 6.1, that additional piece of information is that we have to have a pair of sides that are corresponding to each other that provide a scale factor of 1. So if we have similarity and we have a pair of sides that have a scale factor of 1, the triangle has to be congruent. The pair of triangles are congruent. So go back to the original picture, see if you can identify a pair of sides that have to have a scale factor of 1, and then see if you can finish off the proof to say these two triangles are actually congruent. So again, ADB, trying to prove that that triangle is congruent to A or CDB. So when you're finished, turn the video back on. So hopefully you noticed that both triangles are sharing line segment DB. So we don't have any numbers for the lengths. So the only way to guarantee a segment is going to be equal to another segment without numbers is that they have to share that same segment. In this case, that would be DB. So we can say that DB over DB is always going to equal 1 because what we're looking at here is a segment being compared to itself. So it's the same segment. So are the triangles congruent? And the answer is yes. And again, because the triangles are similar. That's number 1. And number 2 is we got a scale factor of 1. Next video, I will continue with this discussion.